All right, hey guys, so this video is about power rules for derivatives. So this is really the first time that we're going to start looking at some different rules and shortcuts for finding derivatives instead of using that limit definition like we were in class today, because that gets really annoying. So this first one we're going to talk about is the power rule. So we talked a little bit about it in class if you were in there, but if not, then here we go. So if your function is something like f of x equals a number, so I'm just going to call that a, times x to a power of n. All right, so something like 5x squared or 6x to the third or things like that. Then the derivative, f prime of x, is going to equal, here's the rule. We're going to take our exponent and we're going to drop it down. So now our coefficient becomes a times n. And then we're going to have times x to the, and instead of n, we're actually going to have to subtract 1 from our exponent. So we noticed in class that we went from an x squared to just an x. We dropped the we dropped the exponent and multiplied it by the coefficient and subtracted 1. Okay? The other one that we need to talk about is the constant function rule for derivatives. So if your function f of x is just some number a, then the derivative of the constant is actually just 0. The reason for that is we have to almost think of f of x equals a as a times x to the power of 0. And if we use this rule, then we drop our exponent, which is 0, and we would do a times 0 times x to the negative 1. And we know that anything times 0 is just 0. All right, so if it's a constant, then it really just goes away when we take the derivative because it becomes 0. So let's look at some examples here. This first one is p. So when we take the derivative, that's now going to become p prime. The first one that we have here is t to the third. So the exponent is 3, and we're going to bring it down. It becomes 3 times t to the 3 minus 1. Then for the next one, the 6 is there. So 6 times, and we're going to drop our exponent to become a 2 down here, times t to the 2 minus 1. And then we have minus 5 over 3. Technically, there's an exponent of 1 that we're going to drop, times t to the 0. And then we have this 16. That's a constant, which means that derivative is actually just 0. Now, I'm purposely showing you all of these steps. I will never again show you all of those steps, okay? You don't need to do this step here. P prime is actually just going to be 3t squared plus 12t minus 5/3. Okay? We're dropping the exponent and multiplying it by the coefficient, and then subtracting 1 from the exponent. So we went from a t to the third to a 3t squared, 6t squared to 12t, negative 5t to just, negative 5/3 t to just negative 5/3, and then the 16, we know the derivative of that is 0. All right? Let's look at another one. So this one is y equals x to the fourth minus 2x squared plus 2. So y prime is going to equal, we drop the exponent, so now my coefficient is a 4, and I'm going to subtract 1, so it's x to the third. Then I drop my coefficient here, so 2 times 2 gives me 4, and my exponent is now just 1. And the derivative of 2, that's a constant, which means that derivative is just 0. So I'm done. All right. Then let's look at finding derivatives with variable denominators or rational exponents. I know it may not seem like it, but really those are both just fancy ways of saying, hey, we're still going to use the power rule. Variable denominators just means we're going to use some negative exponents. And then rational exponents, those are things like square roots, cubed roots, things like that. So our very first step when we have something like this is to rewrite all powers with negative or fractional exponents. All right, after we do that, we're going to follow the power rule like we were just doing. We're going to drop the exponent and subtract 1. And then our very last step is we have to rewrite the function, the derivative, so that it looks like the original function. So let's take a look at what this might mean. So the first step is to rewrite all the powers with negative or fractional exponents. So when we look at this one here, our first step, rewrite. So f of x is going to equal, we have 4 over x to the 4th. Well, really, that's like saying 4x to the negative 4th. We're going to take that x to the 4th and bring it to the top, which means we make it a negative 4. Minus, we have 3 over x to the 3rd. Well, x to the 3rd, I can bring that to the top and make it a negative x to the 3rd. And now when I look at that, I can just use my power rule to actually find the derivative. So now we're going to use power rule to find f prime. So f prime of x is going to equal, I'm going to drop my exponent and multiply. So 4 times negative 4 is negative 16. And I'm going to subtract 1 from my exponent. This is where it gets weird. Negative 4 minus 1. So here, I'm dropping this, and I'm going to subtract 1. This is actually x to the negative 5th. So be careful with your negatives. Then I'm going to drop my exponent. So negative 3 times negative 3 is a positive 9. And I'm going to subtract 1. So this becomes x to the negative 4th. Our last step is that we have to rewrite it so that it looks like our original function. So our original function did not have negative exponents. It had variables on the bottom, in the denominator. So what that means is we're going to have to write this as f prime of x equals, we have negative 16x to the 5th. Well, negative exponents, we know that means drop it like it's hot. So this is negative 16 over x to the 5th. And then over here, we have plus 9x to the negative 4th. Well, again, x to the negative 4th, that's a negative exponent, so drop it like it's hot. 9 over x to the 4th. And that's our derivative. Okay, let's do one more. First thing here is to rewrite this one. So for step 1, we're going to rewrite f of x. Instead of 3 times the square root of x, we're going to write that as 3x to the 1/2. So you do need to be comfortable converting from square roots to rational exponents, or from cubed roots to rational exponents. Okay? Then we're going to follow the power rule. So step 2 says we're going to do f prime of x. We're going to drop our exponent. So 3 times 1/2 is 3/2. And then we're going to subtract 1. So 1/2 minus 1, we know that that's going to be x to the negative 1/2. Then for step 3, to rewrite this, we need to rewrite it so that it matches the one up here. So this original one had a square root in it, and this has a rational exponent, so we need to make them match. The first thing we can actually do, though, is we know that because it's a negative exponent, we're going to have to drop it like it's hot. So this x to the negative 1/2 really means put it in the denominator with the 2. So this is 3 over 2 times x to the 1/2. And then we know that x to the 1/2 really means the square root of x. So this is 3 over 2 times the square root of x. All right. I know I went through that a little fast, but I think you guys kind of have an inkling about this anyway. If you had any questions, make sure you wrote them down. I'll see you guys on Monday for some practice. I hope you have a really great weekend, and don't forget to wear your pajamas on Monday for homecoming week. See you later. Bye.